Hello everyone, in this video we are going to solve the January 2021 Maths B paper 2 from the International GCSE exam series, paper code WMB1/02. So let's get started. Question number 1. The following formula can be used to change our temperature F degrees Fahrenheit to our temperature C degrees Celsius. So this is the equation referring to the terms F and C. So in part A, it asks you to find F the subject of the formula. So we need to make F the subject of the formula. The given formula has the subject C, but we need to change it, rearrange it so that at the end of the equation, at the end of the solving, we have F as the subject position. So in order to do that, we are going to solve part A here. The equation is C5 bracket F minus 32 over 9. So we are going to first shift the 9 to the left hand side and multiply the 5 with all the terms inside the bracket. So we are left with 9c, and 5f minus 5 into 32 will give you 160. Will give you 160. And now I'm going to just flip it so that the term f is on the left hand side of the equation. So if we flip it, it's going to look like 5f minus 160 equals to 9c. Remember that in terms of flipping, there will be no sign change. So now we are going to shift this 160 to the right hand side. So it will be 5f equals to 9c plus 160, and then finally the 5 to the right hand side. So the equation would look like f equals to 9c plus 160 over 5. So this is the equation. That's how it will look if we make F the subject of the formula. I hope question number 1A was clear enough for you all to understand. Moving to part B, Sean and Kate measure the temperature of a heated iron bar. I don't know the pronunciation is Sean or Cian. I think it's Cian. Cian measures the temperature of the iron bar at X degrees Fahrenheit. So X refers to Fahrenheit. And Kate measures the temperatures of the iron bar at Y degrees Celsius. So Y refers to Celsius. And there is a given equation that is X equals to 2Y. Find the temperature in degrees Fahrenheit of the iron bar. So you need to find the temperature of that given iron bar in Fahrenheit degrees. Not in Celsius but in Fahrenheit. So let us take informations from the equation first. Moving to this page. X was in Fahrenheit. The spelling of Fahrenheit is and Y was in Celsius. There was also a given equation that was X equals to 2Y. So now as X refers to 2Y, we can say that X is F and Y is C. So we can say F is equals to twice C. Now moving to the first part, the equation was given as 5F minus 32 over 9. So this was the value for C. The value for C was 5 bracket F minus 32 bracket close over 9. So now you can just put that value of C into this equation. So let me just label this as equation 1 and this as equation 2. So we are going to substitute equation 2 into equation 1. So we have to write substitute equation 2 into equation 1, and now you will have F equals to twice into the value for C was 5F minus 5 into 32 is 160 over 9, and if you just simplify it, you will have 9F equals to 10F minus 320. And now if we flip this entire thing, you're gonna get 10F minus 320 equals to 9F, and taking all the F together, so 9F minus 9, so 10F minus 9F equals to 320, you're gonna left with F equals to 320, and that's what we were asked to find out, the value of the temperature of the iron bar in Fahrenheit degrees. That is the value of F, the numerical value of F. The numerical value of f is 320 degrees. I hope question number 2 was clear. Sorry, not 2, 1b was clear enough for you all to understand. Moving to the next question. Question number 2. The Earth is assumed to move around the Sun in a circular orbit of 1.5 into 10 power 8 kilometer. So the radius is 1.5 into 10 to the power 8 kilometers. Assuming that the Earth takes 365 days to complete one orbit of the Sun, calculate the average speed in meter per second to three significant figures of the Earth as it orbits the Sun. So in order to find the distance, average distance, we have to first find the total distance traveled. As our Earth orbits the Sun in a circular pathway and the radius is 1.5 into 10 to the power 8, we can easily find out the circumference of that circle, and that would be the total distance traveled for the Earth. So distance traveled is the circumference, that is 2 pi r, so which is basically 2 pi into 1.5 into 10 power 8. So you have a value of that's a very big value, so I'm just gonna write 2 into 1.5, that is 3. And so if you just simplify it, you're gonna get 3 pi into 10 power 8. I'm just gonna leave it like this. And again, you have to find the speed in meters per second, not in kilometer. So in order to convert the kilometer into meter, you need to again multiply it with 10 to the power 3. So you are left with 8 plus 3 is 11. So 3 pi into 10 power 11 meters. So this is the total distance traveled by the Earth in meters. And then we need to find the time. So it takes 365 days to complete one orbit. So now we need to convert 365 days into hour. That is, one day has 24 hours. So 365 days will have 365 into 24 hours. And each hour has 3600 seconds. So time will be 365 into 24. This converts into hours. And then into 3600, this converts the entire time into seconds. So the unit for this is seconds. And now you can easily calculate the average speed. Average speed equals to distance traveled by time taken. Always remember that it is very smart way to gain marks as to write the equations. Whenever you write an equation, you will automatically gain some marks because of the equation. So always try to write the equation or the formula. So the total distance traveled was 3 pi into 10 to the power 8 divided by 365 into 24 into 3600. Now if you calculate it, you get a value of 29885.8, but as your question asks you to keep your answer in three significant figures, so the actual calculated value is 29885.8 meters per second. But when you keep the answer in three significant figures, you're gonna get your answer as 29900 meters per second. So this is the average speed of the Earth as it orbits the Sun. I hope question number 2 was clear enough for you all to understand. Moving to question number 3. Question number 3 gives you a circle with several triangles inside it. Figure 1 shows QRST with center O. SQ is the diameter of the circle. QR is 40 mm. RS is QR is 60 mm. RS is 40 mm. And ST is 50 mm. So without using a calculator, find the exact length in millimeter of QT. Give your answer in the form A root B, where A is an integer and B is a prime number. Show you working clearly. So here the term without using calculator doesn't mean that you can't use a calculator in any step. You can use a calculator for your own preference, but you have to show every step of the maths. So at first, in order to find QT, let us first understand that as SQ is the diameter, that means angle R and angle T would be a 90 degree. Why is angle R and angle T is 90 degree? That is because angle of a semicircle. Whenever the triangle passes through the diameter, the angle opposite of the diameter is always 90 degree. So the reason here is angle of a semicircle. Angle of a semicircle. Then we're just going to focus onto the triangle SRQ. Let me highlight that part. But we are just going to focus on this specific triangle SRQ. So if you focus on specific triangle, let us first write from triangle SRQ. So from triangle SRQ, we can see that SQ is the hypotenuse, and SR and RQ are the adjacent and are basically the perpendicular lines. So we can find the value for SQ as 40 square plus 60 square root. Now we are not going to calculate the value. We're just going to carry this entire term to our next calculation, next part of our calculation. That is, we want to find the value for this line QT, and now we are going to focus onto the triangle STQ. So from or in triangle STQ, we need to find the value for QT. We have the value for ST that was given in the question, 50 millimeters. We have now found the value for SQ, that is root over 40 square plus 60 square. Now in the second triangle STQ, SQ is still the hypotenuse, so the equation would be like SQ square equals to ST square plus QT square. So now if you make QT the subject of it, you are going to end up with SQ square minus ST square root. And now the value for SQ would be 40 square plus 60 square. The entire thing would be under root, and then again there will be a square. This was just the value for SQ square. Then subtract ST from it, that is 50 square, and finally the outer root. Now you are gonna first solve the 40 square and 60 square sum. So you have root and another square, so eventually they're gonna cancel each other out, and you're gonna be left with 40 square plus 60 square minus 50 square root. Now if you make 40 square, you have a value for 1600 plus 3600 minus 2500. An entire thing would be under root. If you calculate it, you get a value of 2700. Now you can simplify 2700 as 900 into 3, and if you square root 900, the value for square root of 900 is 30, so it will be 30 root 3. Now in a question, you have to keep your answer as in the form a root b. A is an integer, here 30 is an integer, and b is a prime number, and here we got 3 as in the position for b, which is again a prime number. So a is 30 and b is 3. So the value for QT is 30 root 3. So this was the entire calculation and explanation for question number 3. I hope question number 3 was clear enough for you all to understand. Moving to question number 4. Question number 4 is the probability maths. Over the course of a week of 7 days, Alan plays a series of games. He plays exactly one game each day. On Sunday, the probability that Alan wins the game is half. On other day, on a day other than Sunday, the probability that Alan wins the game is 1 by 3. The incomplete probability tree diagram gives us below is to give information about Alan's result on a randomly chosen day in a week of 7 days. Complete the probability tree diagram. So at first, there is a, what is the probability of happening Sunday in a week? That is 1 over 7, because there is only one day, that is Sunday. So 1 over out of the entire week, that is 7. So 1 over 7. How many other days or not Sundays can be on a week? So inside a week, that is, there could be 6 days that are not Sunday in a week. That is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? So there are 6 days in a week that are not Sunday. So it will be 6 over 7. Now what is the probability for winning in Sunday? It was given in the question, half. And the probability of not winning in Sunday would be 1 minus the winning probability, half. So it will be again half. And the probability of winning in not on Sundays, that was 1 by 3. And the probability for not winning on not Sunday, on other days actually, that would be 1 minus 1 by 3. That is basically 2 by 3. So this is the complete tree diagram. This is how the complete tree diagram would look. Now in part B, find the expected number of games Alan will win in a week of 7 days. So there are two situations, that is Alan could win in Sundays and Alan could win in not Sunday. So the two conditions are Alan could win in Sunday and the Alan can win in not Sundays. Probability Alan can win in Sunday and Alan can win in not Sunday. That means he can win in both the situations, in Sunday and in on other days. So as we can see, there is an and inside the two conditions of the probability. So we are going to use the and rule, that is the plus rule. So what is the probability of winning in Sunday? That is 1 by 2. And as there are only one Sunday, so it will be 1 by 2 into 1. And according to the and rule, we need to add the two different probability for two different conditions. The second condition was Alan can win in not Sundays. So in not Sunday, the probability for winning the game was 1 by 3. And there are 6 days that are not Sunday. So Alan can win on other days, that is 1 by 3 into 6. Now if you calculate it, you get a value of 5 by 2. So this was the explanation for question number, what was the question? 4B. This was the explanation for question number 4B. I hope it was clear for you all to understand. Moving to part C. I think it has part C. No, it doesn't have any part C. Yes, it doesn't have any part C. So moving to question number 5 then. Question number 5 is about sets. This is the universal set, and A, B, C are 3 sets inside this maths. So here are the information about the sets. Number of elements in A is 45, number of elements in B is 48, number of elements in C are 55. Number of elements in A intersect B are 24, number of elements in A intersect C are 25, number of elements in B intersect C are 27. Number of elements in A intersect B intersect C is X. Number of elements in A prime, B prime and C prime is Y. So at first we need to, in part A, obviously part A asks you to represent all the information in the set Venn diagram, right? So at first I'm going to focus on this last set, that is number of elements inside the A prime intersect B prime intersect C prime. So it basically means that these number of elements are not inside in any of the sets, not in A, not in B or not in C. That means obviously they would fall under the universal set, that is inside the square but not inside any of the circles. So you can write the Y in any positions, like there or any position except inside the circles. You can't write Y inside the circle, you can write Y anywhere in the square but not in the circles. So then we are going to move to A intersect B intersect C. That is basically means the number of elements that are common between all the three sets. So this portion represents the space where we need to write the number of elements that is common between all the three sets, because this specific area is is shared between all the three sets. Like this part is a portion of set A, this part is also a portion of set B, this part is again a portion of set C. So we need to write the number of elements that is common for all the sets in this area. Then we are going to move to the intersecting elements. That is, A intersect B was 24, but A intersect B also contained the X elements, so we need to subtract X from the 24. So you have A intersect B in this area, so you need to write 24 minus X. Again, A intersect C is 25, but 25 also contains that X number of elements inside it. So you have to write A intersect B is actually 25 minus X. And again, B intersect C is 27 and it has X included with it. So you have to subtract 27 minus X. And now moving to the number of elements that are only inside A, only inside B and only inside C. There will be no intersection, no other parts are related. So the number of elements that would be only inside A, that is 45 minus 24 minus X. You need to minus this part, and then you need to minus 25 minus X also. 25 minus X, and then again this entire X at the center. So if you calculate it, 45 minus 24 minus 25, you're gonna left with minus X and one positive, sorry, minus 4 and one positive X. So you can write X minus 4. X minus 4 are the number of elements that are only under the set A. Again, do the same process for set B and set C. So set B was 48, so you need to subtract 48, subtract 24 minus X from 48. Again, 27 minus X from 48, and lastly minus X. So if you do this, you are going to left with X minus 3. And for the last set C, you have 55. So 55 minus 27 minus X, minus 25 minus X, and minus X. So you're going to leave with X plus 3. You can write X plus 3 or 3 plus X any way you want. So this is how the entire Venn diagram looks like after it is completed. These are the highlighted points that you actually need to write inside the Venn diagram. I have put some word solutions inside the Venn diagram. There are not actually necessary steps, like how you have come to the solution for X minus 4, X minus 3 or X plus 3. You don't need to write all the calculations. You can just simply write X minus 4, X minus 3 or X plus 3, and you would still end up with good marks or full marks. So moving to part B, given that the total number of elements inside the universal set were 100, find an expression for y in terms of x. Give your answer in its simplest form. So let me move to this lower portion. In part B, it says number of elements under the universal set is 100. So now we need to just sum up all the numbers that we have wrote in this Venn diagram, and sum up should be equals to 100. So we have X minus 4 plus X minus 3 plus X plus 3 plus X plus 24 minus X, 25 minus X, and 27 minus X, and plus Y equals to 100. Now if you calculate all the numbers together, you're gonna leave with 72 plus X plus Y equals to 100. Now the question asks you to find the value for Y in terms of X. So shift all the things to the right hand side except for Y. So if you shift all the things to the right hand side, you're gonna live with 100 minus 72 minus X. So the value for Y in terms of X is 28 minus X. So this is the answer for part B. I hope part B was clear enough for you all to understand. Moving to part C, Using your Venn diagram and your answer to part B, find the greatest possible value of x. Give reasons for your answer. Okay, so the greatest possible value for x always indicates that part C, sorry. Part C. So the greatest possible value of x, it means that 24 minus x or 25 minus x or 27 minus x, all the variables should be always greater than or equals to 0, or the value for y that you actually found in part B, that was 28 minus x, should also be greater than 0. Now if you calculate the values, you have 24 minus x greater than equals to 0. You're gonna have 24 greater than equals to 0x, so which basically means x is less than equals to 24, right, if you flip the entire thing. And then you have 28 minus x greater than equals to 0, and again you're gonna leave with x is less than equals to 28. Maybe I made a mistake. Let me first flip the entire thing, so it would look like 0 is less than equals to 24 minus x. So now you are just going to move that minus x to the left hand side, so it will look like x is if we have 24 minus x greater than equals to 0 minus x minus 24, so it will have x less than equals to 24. Yes, we have less than equals to 24x. Sorry for the confusion. Yes, so we have x is less than equals to 24. Then again we have 28 minus x greater than equals to 0, and if you calculate it, you get a value of x less than equals to 28. We have 27 minus x greater than equals to 0, so we have x less than equals to 27. And finally there was another term, that was 25 minus x greater than equals to 0, and we have x less than equals to 25. So the greatest value here gives you the value for 24. So the greatest value of x is 24. You can write the greatest value of x is 24. I hope part C was clear enough for you all to understand. Moving to question number D. An element is selected at random from the 100 elements in the universal set. Find the probability that this element is in the set B intersect C prime union B prime intersect C. So first we need to find the value for B intersect C prime. Let me highlight the part which actually indicates to the point, to the value where it refers to B intersect C prime. So B intersect C prime means that we are not going to focus on the C part is entirely not included, but other than the C part, everything inside the Venn diagram is included and need to intersect B with it. So that obviously means this portion. This portion here indicates B intersects C prime. This portion indicates B intersects C prime. So we're going to just write it as B intersect C prime and we also had a set called B prime intersect C. Now B prime intersect C indicates to this portion of the set. Now everything that falls between these two colored regions are referred to be elements under the specified sets, that is basically B intersect C prime and B prime intersect C. Now this refers to as B prime intersect C. Okay, so now we can see that B intersect C prime has 24 minus x, this 24 minus x, this x minus 3, 24 minus x. These are the two terms inside B intersect C prime. So you're going to just move to the end of the paper where we were writing, that was D part. B intersect C prime has 24 minus x and x minus 3. These are the values of set under the set B intersect C prime. And the value for B prime intersect C has 25 minus x, this, and x plus 3. So we are going to again move down to the lower part, and we have found the value for B prime intersect C is 25 minus x and x plus 3. So these are the sets. So these are the elements under the set B intersect C prime and B prime intersect C. So now we need to find the value for probability for these two terms in union. So probability of B intersect C prime union B prime intersect C, and union means just the combination of all the elements under a given set. So all the combination of elements under the given set would be 24 minus x plus x minus 3 plus 25 minus x plus x plus 3. The total number of elements was 100, and this probability was also occurring with the entire universal set. So the entire thing would be divided by 100. Now for the numerator, if you calculate it, this x and x gets cancelled out, this x and x gets cancelled out. So you have 24 minus 3, 25 plus 3. So this 3 gets cancelled out, and we are left with 24 and 25. So plus of 24 and 25 gives you 49 over 100. So the probability of B intersect C prime union B prime intersect C is 49 by 100. I hope question number 5D was clear enough for you all to understand. So moving to question number 6. Solve the inequality 3x plus 5 greater than 7x minus 9. So in part A1, you have 3x plus 5 greater than 7x minus 9. If you shift that 7x to the right hand side, you have 3x minus 7x minus 9 minus 5. You have minus 4x greater than minus 14, and as you have negative 4x on the left hand side, negative 4 associated with the x, so whenever you move that negative 4 to the right hand side, the entire inequality sign will just reverse. So it will be like x greater than minus 14 by minus 4. You have a value for 3.5. So x is less than 3.5. And in part 2, we need to represent this solution onto the number line on the next page. So the number line is here, and for part 2, you have to express that x is less than 3.5 onto this number line. Remember that less than arrow, less than inequality means arrow towards left, right? So if you just focus on this, that the head of the arrow is pointing towards left, and the less than arrow, less than inequality, also points towards left. So less than always indicates arrow towards left. So you have 3.5 here, as the inequality was not less than equal to, it was just less than. So there will be a blank circle on 3.5 and there will be an arrow towards left from it. Arrow towards left from that blank circle. So part 2 is clear. Moving to part B1, solve the inequality x square plus 5x minus 6 greater than equals to 0. So you have part B1, x square plus 5x minus 6 is greater than equals to 0. Now if you just middle term it, like as it is, as you can see, it is a quadratic equation, you obviously have to factorize it. So it will be x square, it will be like 5, so 6 and 1, so it will be negative x plus 6x minus 6 greater than equals to 0. And if you take x the subject, it will be x minus 1 plus 6, so it will be x minus 1 again greater than equals to 0, and you have x plus 6 and x minus 1 greater than equals to 0. You will have a value for x is minus 6 and a value for x is positive 1, but for the inequality I always suggest to draw a graph. As you can see, it is a positive quadratic graph, so it will cut the axis on 2 points, that is minus 6 and 1. This is minus 6 and 1. Positive quadratic graph cutting the x-axis at 2 points, minus 6 and 1. So it refers to the greater than region, that is these regions, outward regions of the graph. Outward region means that the value for x must be greater than 1, greater than equals to 1, and the value for x must be less than equals to minus 6. So the inequality should be, or the range of values of x for part B1 should be x is greater than equals to 1 and x is less than equals to minus 6. And now again you need to write these inequality, represent this solution onto the number line on the next page. So we have greater than equals to 1, x is greater than equals to 1, and x is less than equals to minus 6. As you can see that there are the inequalities have equal to sign associated with it. That means there will be a filled up circle now. So greater than equals to 1 is here with a filled up circle, arrow towards right, and less than equals to minus 6 is here with a filled up circle, arrow towards left. Part B2 is clear, I hope. Moving to part C, write down the set of values of x for which both the inequalities satisfy. So now I am going to write both the inequalities onto this extra line given here for my own use. So the value for part A1 was x less than 3.5. So it was x less than 3.5 was from this inequality, and for the part B2 it was 1 greater than equals to 1 and less than equals to 1. Now if you highlight the regions that are common between both the inequalities are these regions. Right, between 1 and 3.5. Sorry, I have made a mistake. It should be on 3.5. So this is the one of the region that is common between both the inequalities, and the other common region is this, which basically goes to infinity, because there is no end for the arrow. There the x is less than equals to -6. Now less than equals to could mean to negative infinity, and the upper arrow means less than 3.5, and less than 3.5 could also mean to less than mean towards the negative infinity. So you have the value for this positive this common region is x less than 3.5 and greater than equals to 1, and here you have x less than equals to -6. So the value of x, or the range of, or the set of values of x that satisfy both the equation are these two values, are these two ranges. So set of values of x, values of x are 1 less than equals to x less than 3.5 and x greater than equals to -6. So this is the end for question number 6. Entire question number 6 ends here. Yes, there are no other parts left. I hope question number 6 was clear enough for you all to understand. Moving to question number 7. Given that a is inversely proportional to root b and b is inversely proportional to c power 3, complete the following table. At first, we are going to find an equation that connects a and c together. So we are just going to focus on the term a and root b first. So we have to find the value for an equation that connects a and b. That is, a is inversely proportional to root b, which means a is equal to k by root b. Now this is the value for this is the relationship for a and b. Now again, if we focus onto the relationship between b and c, it is stated that b is also inversely proportional to c cube. So let me label this equation as equation 1, and we are going to have another equation, that is b is equals to k by c cube. b is inversely proportional to c cube, and this is the value or this is the equation 2. Now I'm going to substitute equation 2 into equation 1. So substitute equation 2 into 1. Now if you substitute equation 2 into 1, you get a equals to k over k by c cube, entire thing under a root, and if you just like rearrange it, it will look like a equals to k by k power 0.5 by c power 3 by 2. As the denominator is in fraction, so it will obviously be inverted, and the thing would look like finally is a equals to k by k half into c power 1.5. If you just simplify it, k divided by k half means eventually 1 minus half is k power half. So the final equation that connects a and c together is k power half. K power half basically indicates to root k into c power 1.5, and this is the final equation that connects a and c together. And now using this equation, you can find the value for k and then the value for c and a as required from the table. So we are going to first use the first set of values, that is 16 and 240. So using the first set of values, let me write first set of values. First set of values, the value for a was 16, the value for c was 240. So a equals to root k into c power 1.5. If you make k the subject, it will be a divided by c power 1.5. The entire thing would be under a square, and if you put the values of all the alphabets, that is 16 over 240 with a power of 1.5, an entire thing under a square, you get a value of 1 over 54,000. So the value for k is 1 over 54,000, And now using the first value, we have calculated the value for k, and then using the value for k, we can find the value for c in the second value and a in the third set of values. So let me move to the second set of values. In the second set of values, the value for c is missing. So we are now using the value for second set of values. Second set of values. For the second set of values, the value for a is 250 and the value for c is unknown. The value for k that we calculated in the first part, that is 1 over 54,000, is going to be same for all the set of values. First set of value, second set of value, and third set of value. So for the second set of values, we need to calculate the value for c. The equation that we found out, that was a equals to root k into c power 1.5. 1.5 basically means 3 over 2. So we are going to make c the subject, and it will be a over root k. Now the power on c was 1.5, that was 3 over 2. So whenever you invert 3 over 2 to the right hand side, it gets inverted, and the entire power would look like 2 over 3. Just the inverted version of 3 over 2 is 2 over 3. And now you have to put the values of all the alphabets inside this given equation. A is 250 over 1 by 54,000 under a root, and the entire thing would be inside a power of 2 over 3. If you calculate it, the value for c for the second set of values is 1500. It's 1500, and now we have to move to the final set of values, that is the third set of values. In the third set of values, you have the value for a is missing. So third set of values, for the third set of values, the value for c is 135, and the value for k is going to be the same, 1 over 54,000. So the equation is a equals to root k into c power 1.5, that is the value for k is 1 over 54,000 root into the value for c is 135 power 1.5. And if you just calculate, you get a value for a is 6.75. So the value for a for the third set of value is 6.75. I hope question number 7 was clear enough for you all to understand. So moving to question number 8 then. Question number 8 is about kite. Figure 2 shows a kite ABCD in which AB is 6, BC is 8, and angle ABC is 90 degree. AEC and BED are straight lines. Part A, calculate the length in centimeter of AC. So we need to find the value for the length AC. As we can see, ABC is a right angle triangle, and as angle B is 90 degree, which makes AC the hypotenuse of the triangle ABC. So we can obviously easily calculate the value for AC using the Pythagoras theorem. So question number 8A, AC is 6 square plus 8 square. Entire thing would be under a root, square root. So 6 square plus 8 square under a square root. If you calculate it, you get a value of 10. The value for AC is 10 centimeters. So part A is done. Moving to part B, calculate the area in centimeters square of ABCD. As it only has 2 marks, and we can see that as it is a kite, ABC will obviously a mirror of ADC. So you can just calculate the value for ABC, the area of the triangle ABC, and you can just multiply it with 2. to find the entire area of the kite ABCD. So we are just going to use the same, use that method. That is part B. Sorry. So part B is the area of the kite, ABCD is half into 6 into 8, half into base into height, and you need to multiply it with 2, as there were two similar triangles like this that make up the entire kite. So if you calculate it, that is half cancels 2 and 6 into 8 is basically 48. So you have the value 48 centimeters square. Moving to part C, show that BE is 4.8. So if we highlight the diagonals of the entire kite, you can see that BE is this part, one diagonal, BD is one diagonal, and AC is another diagonal. We have already calculated the value for AC as 10 in our part A, and we have the area of the kite. The formula for the area of the kite is diagonal 1 into diagonal 2, and we need to find the value for BE, which is half of the one diagonal, that is half of BD is BE. So we can easily calculate BE by using the equation. Part C, area of kite is again 48, but diagonal 1 into diagonal 2 makes up 48. Diagonal 1 was BD and diagonal 2 was AC, which makes up 48. Now we can write BD in simplified format, that is 2 into BE no, maybe I made a mistake. Wait, the value for BE has to be 4.8. We need to just focus on the other triangles. Let me cancel it. So for to find the value for BE to be 4.8, we need to use the equation, that is focus on this triangle, that is ABE, and we are now going to consider AC as the base and BE the height of the entire triangle. And we can see that both of the triangles, area of both the triangles sum up to 48. That means just area of one of the triangle would be just half of 40, that is 24, right? So part C, in part C we are just focusing on the triangle ABE. So in triangle ABC, just in triangle ABC, we have area of this triangle ABC, area of triangle ABC is 24, that was half into 6 into 8, and we can also find it using the equation half into base is AC and height is BE. AC was 10 and 24, and if you make BE the subject now, that would be 24 into 2, 48, 48 by 10 is 4.8, 24 into 2 by 10, so you get the value for BE as 4.8 centimeters. So with this, our value for C is done. I hope C is clear for you all to understand. Prove that triangle ABE is similar to triangle BCE. So triangle ABE and BCE are two triangles under the triangle ABC. Let me highlight the two triangles here. So this is triangle ABE and the other triangle is BEC. That is this portion of the triangle. So we need to make sure, prove that the triangle ABE and BCE are both similar triangles. So in order to do that, let me first draw the triangles in a way so that we can actually compare the sides together. So we are going to write triangle ABE as this. Make E the top of the triangle. A is the top, E is below it, and there should be point B, and we are going to draw BEC just the way it is. So if we write, when I draw the two triangles here, so point part D is here, this is A, E was below A, and there will be point B, and we have another triangle BEC, BEC. Now again we move back to the entire original diagram. We can see that AC was the diagonal and BD was also the diagonal, and we know for the kite the diagonals always intersect each other. That means here the angle will be 90 degree. So from that knowledge we can say that angle AEB and BEC are 90 degree. So let me write that first. Angle AEB and angle BEC are equal to 90 degree according to the reason that BE and AC are diagonals of the kite. Right, so BD and BD perpendicular to AC as diagonals. Of the kite. Okay, then we need to prove the ratio of the sides are kind of similar. We have the value for BE is 4.8. The value for AB is the value for AB was 6 and BC was 8. AB is 6 and BC was 8. We have the value for EB. Right, BE again here it will be 4.8, and we need to find the value for AE here. So we can easily find the value for AE so that we can compare the length of AE and BE together. So the value for AE is, we're just focusing in the triangle ABE. So from triangle ABE, the value for AE is 6 square minus 4.8 square root. If you calculate it, you get a value for 3.6. So the value for AE is 3.6. Now if you find the ratio of the sides AB and BC and AE and BE, you're gonna have the same ratio. So let me first divide AB by BC. or BC by AB. So BC by AB is basically, BC is 8, 8 by 6. 8 by 6 will give you a value for 4 over 3. And then again, if you divide BE by AE, BE by AE, BE by AE gives you a value for 4.8 by 3.6 gives you a value for again 4 by 3. So the ratio of the sides are similar, one of the angle is similar. So obviously triangle ABE and BEC are similar to each other. This is basically angle, side and side. So it refers to the SAS explanation of the mark scheme. So we can just write triangle ABE and triangle BEC are similar at the end. So with this, our question number 8 ends. I hope question number 8 was clear enough for you all to understand. Moving to question number 9. A, B, C, D. Yes. So moving to question number 9. Question number 9 is about matrix. The point with coordinates 1, 2, 1, 5, 3, 2 are the vertices of triangle A. On the grid, draw and label triangle A. So triangle A is 1, 2, x-axis 1, y-axis 2, and 1, 5, and 3, 2. So this is triangle A. Part A is done. We just had to label the triangle A onto this graph. Draw triangle A onto this graph. Moving to part B. Triangle B is the image of triangle A under reflection in the line y is equals to minus x on the grid. Draw and label triangle B. So reflection of triangle A under the line y equals to minus x indicates that if the coordinate for triangle A was 1, 2, 1, 5, 3, 2, as B is a reflection of A under the line y is equals to minus x. That means the coordinates of B will be inverted and negative to this. That is 1 would be 1, 2 was the first point for triangle A. The first point for triangle B would be minus 2, minus 1. The second point for triangle B would be minus 5, minus 1. And the last point for triangle B would be minus 2, minus 3. And now in part B, you need to draw the triangle for triangle B on the grid. So triangle B on the grid would be minus 2, minus 1, this part, minus 5, minus 1, this part, and minus 2, minus 3. Minus 2, minus 3. So this is triangle B. This is triangle B, and also the end for our part B. In triangle C, part C, triangle C is the image of triangle A under the transformation with matrix M, where M is 0, minus 1, 1, 0. So we need to find the matrix product M, right? We have to show that matrix product of M is, what would the matrix product of M and M? So matrix product of M would be 1, I always write the 2-column matrix at the front, so 0, minus 1, 1, 0, and then you need to multiply it with the 3-column 1, 2, 1, 5, and 3, 2. So we are just going to be moving the part as first row, first column. That is, first row is 0, 1, minus 2, minus 1 is basically 0, minus 2. And then again, first row, second column is going to be 0, minus 5. First row, third column is going to be 0, minus 2. Second row, first column would be 1 plus 0. Second row, second column would be 1 plus 0. Second row, third column would be 3 plus 0. And if you just simplify it, you get the value for minus 2, minus 5, minus 2, and 1, 1, 3. So these are the coordinates for the matrix M, or you can say the coordinates for triangle C. And in part D, you need to draw the triangle C on the graph. So the coordinates of triangle C are -2, 1, -5, 1 and -2, 3. -2, 1. I made a mistake for drawing triangle B. That is, triangle B should not be in the positive side, it should be in the negative side. The value for triangle B was -2, -1, -5, -1 and -2, -3. So this should be triangle B. Triangle B, and triangle C should be -2, +1, -5, +1 and -2, +3. So this is triangle C. And moving to part D, hence on the, part D is done. Moving to part C, part E. Describe fully the single transformation that maps triangle B onto triangle C. So we can see that the transformation that maps triangle B onto C is reflection in the x-axis, right? We can see that under the reflection of x-axis, triangle C becomes the image of triangle B. Triangle C becomes the image of triangle B under the reflection of x-axis. So we can write part E here as reflection in x-axis. In x-axis. So moving to part F, the N transformation that maps triangle B on triangle C is represented by matrix N. State giving a reason for the matrix N square. So we have a chart that shows the value for matrix on the reflection or on x-axis, on the reflection in x-axis. So the value for the matrix for the reflection on x-axis is represented as N, and it is basically 1, 0, 0, -1. This is the value for the matrix for the reflection in x-axis. And the question wants you to find the value for N square, that is, multiply this again with this. So N square would be 1, 0, 0, -1 multiplied with again 1, 0, 0, -1. And again using the same method, first row, first column, first row, first column, and again second row, first column, second row, first column, you will get a value for first row, first column is 1, first row, second column is 0, first row, second row, first column is 0, and second row, second column is +1. So the value for the reflection in x-axis matrix square is 1, 0, 0, 1. And with this, our question number 9 ends. Moving to question number 10. Question number 10 is about vectors. Figure 3 shows the triangle OAB, where OA is 12A, OB is 6B, and M is the midpoint of OA and N is the midpoint of OB. So we have few things written here, that is OA is 12A and OB is 6B, and M is the midpoint for OA, that means OM would be half of OA, that is basically 6A, and N is the midpoint of AB, that means not ON but AN or NB would be half of AB. Now you have to give your answer. Also there is a line given that point P on BM is such that BP is to BM is 2:3. That is, point P divides the line BM into the ratio 2:3. That is, BP would be 2 and PM would be 1. Part A, simplifying your answer, find in terms of A and B. Part 1, BM. You need to find the value for BM. So you can easily use the lines OB and OM. The value for OB is 6B and OM is 6A, and again MA is going to be another 6A, and you need to find the value for BM. You can see the equation would be OB plus BM equals to OM. So you need to write OB plus BM equals to OM. Now if you make BM the subject of this, you have OM minus OB. OM is basically what? OM is 6A minus OB is 6B. So this is the value for BM, 6A minus 6B. This is the solution for A1. I'm moving to A2, that is OP. So first, for the value for OP, we need to find the value for BP or PM. Either of the value need to be calculated before we can find the value for OP. So I'm just going to focus on the value for BP. The value for BP would be 2/3 of BM. How did I calculate this? Let me first explain this. Now it was given in the question that BP is 2, BM is 2:3. We can write ratios as fractions, so it basically means BP over BM is 2/3, and if you just make BP the subject, it will be BP 2/3 into BM. And now if you put BM inside this, so it will be BP 2/3, BM was 6A minus 6B, and 2/3 6 means basically BP is 4A minus 4B. So the value for BP is 4A minus 4B. And then again, moving to the entire diagram, figure 3, we have to find the value for OP. So this is the value for this is the line that we need to find the value for it, OP, and BP is in this line. So we can see the triangle OPB, and OB and BP refers to the same direction, whereas OP is in the opposite direction. So the equation will be OP equals to OB plus BP, and OP would be, OB is 6B plus BP is 4A minus 4B. So 6B minus 4B is 2B. So the value for OP is 4A plus 2B. So this is the end for part A. On part B, it says, hence show that OP and N are collinears. That means that OP and N are points of a same straight line. We can see that if you extrapolate the line, we can see that if we extrapolate this line from P, it does get connected to point N and forms a straight line with 3 points on it, O, P and N. Now we need to just prove it using the collinear methods. So we already have the value for OP is 4A plus 2B. Now we need to find the value for ON and PN. So first let us find the value for ON. In order to find the value for ON, we need to have the value for NB. And NB is obviously half AB. We have already stated that at the start of our explanation. First we need to find the value for AB now. So part B is kind of lengthy. We are first finding the value for AB. Now AB is OB minus OA. OB was 6B minus 12A. So this is the value for AB, and now we need to find the value for NB. NB is half of AB, so NB is half of AB. AB was 6B minus 12A. Now half of 6 is 3 and half of 12 is 6. So NB is 3B minus 6A. And now to find the value for ON, we can see that OBN, in triangle OBN, OB is in the opposite direction, whereas ON and NB are in the same direction. So the equation would be like it will be ON plus NB is equal to OB. And if you make ON the subject, you have OB minus NB. OB was 6B minus NB was 3B minus 6A. Now it eventually becomes 6B minus 3B plus 6A. So you have 6A minus 3B. So you have the value for ON as 6A minus 3B, and if you take 3 common out of it, you have if you take 3 common, you have 2A minus B. Now this is the value for ON. Now we need to find the value for PN, that is this portion PN, and in order to find the value for PN, we have BP and BP and NB. Now you can just simply find the value for PN. For PN, we are focusing on the triangle BPN, and we can see that BP and PN goes in the same direction, and we're going to consider BN instead of NB. So now we are focusing into the triangle BPN. Inside BPN, we are using the words BP plus PN equals to BN. Now PN is the term that we actually need to find the value for. BN is the opposite of NB. Opposite of NB would mean that minus 6A would become positive 6A, and positive 3B would become negative 3B. So BN minus BP, BN would be 6A minus 3B, and BP was at the top. BP was 4A minus 4B, so minus 4A minus 4B. Now if you remove all the brackets, you have 6A minus 3B minus 4A plus 4B. So 6A minus 4A is 2A, and minus 3B plus 4B is plus B. So we can see that PN is 2A plus B. So PN is this. We have our other 3 values as PN is 2A plus B. The other 2 values to prove that ONP are collinears are OP, that was 4A, OP was 4A plus 2B. Now again we have to take something in common, so we are going to make OP as 2A plus B. So OP is 2A plus B. Now 2A plus B was PN, so we can write OP is 2PN. Another value for ON was 3 2a plus b. Now 2a plus b is again pn, so we can write on as 3pn. And in order to prove that OPN are collinears, we need to just find the ratio of it, that OPN have a ratio of 2:3, right? So we can just write OP is to ON is 2:3. And now we can finally say OP and N are actually collinears. So with this, our question 10b ends. I hope question 10b was clear enough for you all to understand. So this was the entire calculation for question 10b. Moving to question 10c, given that the modulus of A and modulus of B are both 1 and that AOB is 70 degree, find the length in centimeter to 3 significant figures of OP. So let me rub this thing. The angle of AOB is 70 degree. It is given. And now OM was 6A, MA was again 6A, OB was 6B, and you need to find the value for OP, the numerical value for OP, no more vector values for OP. You need to find the value for numerical value for OP. If you focus on the triangle OBM, and as the value for A and B are both 1, so OM also refers to 6 into 1, 6, and OB also gives you a value for 6 into 1, 6. That means in triangle OBM, it is basically an isosceles triangle with similar sides. OBOM indicates angle B, this portion, and angle M, and angle M, these portions are will have the same value. This will be X, and this can be also considered as X. So we can easily find the value for OP using these values. So let's first move to the value for angle. So we are now actually on the part C. Let me first draw a small simplified diagram of the entire triangle. This is how the vector diagram was looking like. OMA, and this was B. This is somewhat point P, and this is somewhere point N. We have 6A here, and 6B here, and the angle is 70 degrees here. AOB is 70 degrees, and we have now focused in triangle OBM. As we can see that OB equals to OM, so it basically means angle OBM equals to angle OMB is equals to X degree, as it is an isosceles triangle. So the value for X would be 180 minus 70 degrees over 2. So the value for X are 55 degrees. Now to find the value for OP, we need to find the value for BM first, the numerical value for BM. So we can usually use the cosine rule to find the value for BM. So to find the value for BM, we are now focusing on the triangle OBM, not on OBP. We are now focusing on the triangle OBM. So in triangle OBM, BM is the opposite side of the angle 70 degree. So we can use the cosine rule. BM, that is 6A, the value for A and B are 1, so OB becomes 1, so OB becomes 6, and OM also becomes 6, so it will be 6 square plus 6 square minus 2, 6 cos 70 degree, an entire thing under our root, and if you calculate it, you get a value of 6.88. 6.88 is the value for BM. Now from our vector part, we already know that point P divides the length BM under the ratio 2, 3. So if we now focus on the triangle OPB, BP is 2/3 of the entire BM length. I'm gonna focus on, sorry, this is one, and we're gonna focus on OPM side of the triangle. So in triangle OPM, we are now focusing on in the triangle OPM, where OM is 6 and we need to find the value for PM. PM is basically 1/3 of BM. So 1/3 of BM is 1/13 into 6.88. So let me first write PM is 1/3 of BM. So that is basically 1/3 into 6.88, and you get the value for 2.29. And now you can you have the value for angle M is 55 degree, as these two were considered as angle X. Angle X was 55 degree. Angle M is the opposite of OP, so you can easily use that 55 degree to find the value for OP using the cosine rule. So OP would be 6 square, sorry, OP becomes 6 square plus 2.29 square minus 2, 6, 2.29 cos 55 degree, and under an entire root, if you calculate it, you get a value for 5.05. So the value for OP, numerical value for OP with 3 significant figures, is 5.05. And here the this value was the length of PM, this was the length for OM, and here the 6 are the length of OM and OB. I hope question number 10 was clear enough for you all to understand. Moving to question number 11. Question number 11 is about equation graph. The equation of a curve is y equals to fx, where fx is a cubic equation. We need to complete the table. So there are 3 missing values for y, this, and this. So to find the value for these, we need to substitute the value for x minus 1 and 0.5 and 2.5 into the given equation. So when we substitute the value for minus 1 into this equation, you get the value for y is 9. And again, when you substitute the value for 0.5 into the equation, again this equation, you get the value for y is 17.625. But as we can see that all the values of y are kept to one decimal place, so we are also gonna keep our value is as 17.6. And again, we need to substitute the value for x is 2.5 into the equation x cubed minus 10x squared plus 20, and you get a value of minus 26.875. But we are gonna stick to one decimal place, so it will be minus 26.9. 26.9. So part A is done. For part B, you need to draw the graph. So the graph plotting is quite tough. For me, because I need to draw this on a digital screen. The first point was minus 2 and minus 28. So it is basically there. Minus 2 and minus 28 here is here. The second point was minus 1.5 and minus 6. So minus 1.5 and minus 6 is here. The other point was minus 1 and positive 9. Minus 1 and positive 9 is here. Other points were 0.5 and 17.6. So 0.5 is here, minus 0.5, and 17.6 is approximately here. And the maximum point was 0 and 20. 0 and 20. And then at positive half, you have again at 17.5, positive half. At negative 1, you have at 11. So positive 1, you have a coordinate on y at 11, and on 1.5 you have a coordinate 1, 1.5, 1, and at 2 you have a coordinate at minus 12. So here a minus 12, and at 2.5 a coordinate at 27, 2.5 a coordinate at 27. And again at 4, at 3. At 3 there is a coordinate at 41, 2, 3. Minus, 40, 41, 2, 3. So there. So these are the coordinates. Now I need to connect all the points together to produce a smooth curve. Mine will not most probably be a smooth curve. So this is how the entire curve for 11 should look like. I hope the curve plotting was clear for you all to understand. So now I am moving to part C of 11, and part C has a very complicated terms. That is, a different curve C has equation y equals to gx, where b is also equals to gx, and the differentiated value for b is equals to fx. So which basically means that for part C, y is equals to gx, and again b is equals to gx. So we can basically write y is equals to b, right? And again the differentiated value for b is equals to fx. So the value for fx, that you have x cube minus that 10x square plus 20, is equal to the differentiated value for b. Now if you want to find the value for b from this fx, you need to integrate it, and integration of db by dx will eventually give you b, and integration of fx. So if b is the equal to integration of fx, you can finally write as y is integrated value of fx. And question says that curve C has two turning points. Let me write this as label as equation 1, this is labeled as equation 2, and when we substitute equation 1 and 2, you can finally get this final one, y is equal to integrated value of fx. So moving to this line, the curve C has two turning points between the range minus 2 to 3. Use your graph to find the x coordinates of these two turning points on the curve C. So you need to find the turning points. And how do we find the turning points? By differentiating it. So again, if you differentiate y, that is dy by dx, that is basically after what you get after integration of fx, you need to again differentiate it. Now when you differentiate an integrated equation, you're going to end up with that same simple fx, right? So fx, and fx is 0. So we need to find the value for x coordinates wherever fx is 0. So Now move on to the graph, and you can see that at this point, at this x coordinate, fx is 0, and again at this x coordinate, fx is 0. We can see that it creates at minus 1.4, and at approximately minus positive 1.5. So these are the 2 points of x for which the fx is 0, and whenever fx is 0, at fx is 0, these are the turning points for the curve C, for that gx curve. So we have found the x coordinates for which fx is 0, that is x is minus 1.4 and x is 1.5. And moving to part D, part C is done. I hope part C was clear enough for you to understand. Part D, referring to your graph, determine which of these two turning points is a maximum and which is minimum. Explain your reasoning clearly. So we are going to first focus on the first value, that is minus 1.4. From the graph, you can see that minus 1.4, if you increase the value for x, that is if you move from minus 1.4 to minus 1, you can see that the graph is increasing, right? The graph is going up, which means that minus 1.4 would most probably be the minimum value, because after this point the graph moves up. So we can say that atho is the minimum value, is the minimum turning point as the graph goes up, and then moving to the next point, that is 1.5, and this is the 1.5 portion, and if you increase the value for x, that is let us consider 0.2. So when you use the value for x 0.2, you can see the graph is decreasing, right? So after 1.5, the graph has a decreasing pattern, which means that 1.5 must be the maximum value of that C curve. So 1.5 is the maximum value turning value or turning point as the graph goes down. So with this, our question number 11 ends. I hope question number 11 was clear enough for you all to understand. Moving to the last question of this paper, that is question number 12. Question number 12 is about the exchange rate, foreign exchange, maths. So Indri buys 1,000 Hungarian dolls in Budapest to sell in Austria. She pays in Hungarian forints. So she buys 1,000 Hungarian dolls. So Indri pays 1,900 forints for each small doll, and she pays 10,300 forints for each large doll she buys. So the number of small dolls that Indri buys is 4 times the number of large dolls she buys. So let us consider the number of large dolls to be x, and which makes the number of small dolls to be obviously 4x, as it was 4 times the large dolls. So let me write it down here. Part A, large dolls are considered to be x number of large dolls, and small dolls are considered to be 4x. Now you can find the number of dolls for large or small by making an equation: large doll plus small dolls equals to 1,000, because at the end of the day she bought 1,000 dolls altogether. So you have 5x equals to 1,000, so x would become 1,000 over 5. So you have the value for x as 200. That means she actually bought 200 large dolls, and 4 into 200 is 800 small dolls. So basically means 200 large dolls and 800 small dolls. And she paid 1900 forints for each small doll and 10,300 forints for each large doll. And now it will calculate the total cost of the 1000 dolls. So the total cost would be 1900 into 800 for all the small dolls, plus 10,300 into 200 for all the large dolls. And if you calculate it, you get a value of 358,000 forints. So part A is done. I hope part A is clear enough for you to understand. Moving to part B, but before part B there is a big passage which says that INRI has to pay 100 euros to transport the cost from Hungary so that she can sell them in Australia. So the transportation cost is 100 euros. Initially the price of each small doll that INRI sells is 8 euros. So in Austria she sells the small dolls each for 8 euros, and the price of each large dolls that INRI sells in Australia is 40 euros. And she sells 80% of the small dolls at 8 euro price and 7 by 8 of the large dolls at 40 euros price. She then reduces the price for each of her remaining dolls by 40%, and she sells all the remaining dolls. When INRI bought the dolls, the exchange rate was 1 euro equals to 327.6 forints. Calculate the total cost in euros to two decimal places that INRI made by selling all 1000 dolls. So let us first find the initial selling price and the final selling price. The initial selling price was that 80% of the dolls were sold at 8 euros and 7 by 8 of the large dolls were sold at 40 euros. So moving to this page. So we have initial selling price. For the initial selling price, she sold 80% of the 800 small dolls with a cost of 8 euros each. So small dolls, she sold 80%, that means 0.8 into 800, 80% of the small dolls with a price of 8 euros. So if you calculate it, you get a value of 5120 euros. And for the large dolls, she sold 7 out of 8 of the 200 large dolls with a price of 40 euros. And if you calculate it, you get a value of 7,000 euros. Now the leftover dolls were sold at 40% less price. 40% less price means 60% of 8 and 60% of 40, right? So final selling price was for the leftover small dolls. That means after selling the 80% of 800 small dolls, how many small dolls were left? So leftover small dolls are 800 minus 0.8 into 800. So you have 800 minus 0.8 into 800. You have 160 dolls, 160 small dolls left over, and leftover large dolls are 200 minus 7 by 8 into 200. So you have 25 large dolls, and each large dolls and small dolls were sold at a 40% reduced price. That means 60% of 8 euros and 60% of 40 euros. So the final for the final price, the small dolls would cost or would give her 160 into 60% of 8, and for large dolls she would get 25 into 0.6 into 40. So the price for small dolls would be 768 and the price for large dolls would be 600 euros. And now, in order to find the total amount of money she got in Austria is total cost in Austria is that 5120 plus 7000 plus 768 plus 600. If you add all this together, you get 13,488 euros. And now we need to find this is the total selling price. Total selling price, not cost, but selling price in Austria. Now the cost price was in Hungarian forints. The cost price was 358,000 forints plus it took 100 euros to transport the dolls from Hungary to Austria, right? So we have to add that to our cost price too. So we need to first find the conversion of these 358,000 forints to euro, as we need to keep our answer in euros. So first the conversion rate was given as 327.6 forints was equal to 1 euro. That means 358,000 forints would give 358,000 by 327.6, and if you calculate it, you get a value of 358,000 by 327.6. You have a value for 109.27.96. So 109.27.96. But for the total cost price, we have to add 100 because there was a shipping charge, transporting cost from the dolls from Hungary to Austria. So total cost price was 109.27.96 plus 100 would give you a value for 11027.96 euros. So this is the total cost price for 11027.96 euros. And now to find the profit, again if we move back to our question part B, calculate the total profit in euros to two decimal places that Indre made by selling all 1000 dolls. So you just need to subtract the cost price from selling price. So profit is 134,800 minus 11027.96. If you subtract it, you get the value for the profit, that is 2460.04 euros. So with this, our entire question part B ends. It was a very lengthy maths. Moving to part C. Calculate the percentage profit to three significant figures that Indre made. So percentage profit is basically profit divided by cost price into 100, which is very easy. Now we have the profit, percentage profit. So profit is 2460.04 over the cost price 1027.96 into 100%. If you calculate it, you get a value of 22.3%. So this was the percentage profit. And moving to part C2, State how much profit in part C1 would be affected if the total profit calculated in part B had been in forints. So percentage profit would always be same, doesn't matter if you calculate the profit in forints or in euros or in dollar or in pound. It really doesn't matter. The profit will be the same in percentage profits, actually will be the same in every unit of currency. So part C2 would be the percentage profit would be same. Would be the same. So with this, our entire question 12 end and also the entire question paper for January 2021 paper 2. I hope the explanation for this entire question paper was clear enough for you all to understand. I'm going to start making more frequent videos in my channel, and I'm going to upload more videos before the Jan 23 candidates. So I hope it was clear enough for you to understand. So thank you for watching.